So you guys are probably able to get this to this point. Okay, so now today's part, this is part 3. Okay, where we're gonna work in the trig stuff. Okay, so it's same idea. You just have to think about my trig derivatives. So I'm thinking of, what do I take the derivative of to give me cosine? Okay, so sine of u gives me cosine u. So sine u is just sine for x plus c. That would be the answer to that one. Okay, so it's really, and think about it, if you're thinking, oh coach, you're lying to me. Let's take the derivative of this. So let's take y prime. So you have 1/4. The derivative of sine is cosine, all that stuff, times the derivative of the inside, which is just 4. And you see how your 4 in the top and the 4 in the bottom cancel each other out, and you're left with the exact same thing that you started with. Okay, so this is the correct antiderivative. So 13 says the integral of sine cubed x. So really, you could rewrite that like this. Sine x to the 3rd power times cosine x dx. Okay, so what we're going to do is we're going to let, usually, what's in parentheses, okay, sine x is going to be our u. So we're going to kind of follow our little rules to ourselves here. So if u is sine of x, du dx, derivative of sine is cosine x. Okay, technically that's over 1, correct? So now we're going to solve this for dx. So pretty much, essentially, you just flip it. 1 over cosine x du.
Thank you.
Okay, so now we have something for this dx part. All right? So look what happens. You have u to the 3rd power, u to the 3rd power, cosine x, and then this dx turns into 1 over cosine x du. So the cosines cancel each other out. Cosine x over cosine x cancel. That's exactly what we wanted to happen. All right? You don't have to now. Now you're just doing anti-power rule. U to the 3 plus 1 is 4 over 4. Right? Plus c. And so this final answer would be sine x to the 4th over 4 plus c. You could also say 1 over 4, then have your sine to the 4th x plus c. Either one of these would work. Those are equivalent to each other. All right. So right here, let's pick our u wisely. Okay? I'm going to pick my u to be 1 minus sine x. The thing that's all under the radical. That's what I want to be. So if you take du dx right here, so the derivative of negative sine is negative cosine x. So now you solve for dx, right? This is my little box of stuff. Dx is negative 1 over cosine x du. Okay? So look, when you plug all that junk in, you got cosine x times, you have the square root of u, times negative 1 over cosine x du. Now what cancels? Cosine x will cancel. Okay, so I'm going to rewrite this as the negative integral of u to the 1/2, because square root of u is just u to the 1/2 du. And now, guys, we're ready to do the anti-power rule. So you have a negative. You got u to the 3/2 all over 3/2. Right? Yeah. Plus c. So that fraction in the bottom really is like saying 2 over 3. Correct? So this gives you negative 2 over 3 u to the 3/2 plus c. So now we're going to plug that u back in. All right, so that's 1 minus sine x as our u. So we're going to put in, it's usually what's in parentheses, and that part is actually what's usually in parentheses. Okay, so the 10x right there. All right. Yeah, it does look like stand, doesn't it? There's actually a stand pattern that's in there, but you'll figure that out later. Okay, so we're going to let u be 10x. All right. So now du dx is 10. So dx is 1 over 10 du. So we're probably getting really good at doing this now because we've been doing that same process over and over and over again for solving for the dx part. So I know that out here for dx, I'm going to have 1 over 10 du. All right, so my integral now looks like the tan of u secant u times 1 over 10 du. So secant, tangent, right together. One of your list of rules says the integral of secant tangent is just secant. Mm-hmm. So this, by rule, we got 1 over 10 secant u plus c. Okay, that's one of our rules from a couple pages ago in the notes. Go back. You can go back and find that rule that we have. So now all it is just plugging in the u. So you have secant 10x plus c. Okay. A little bit different. So sometimes it appears that it can't be taken with U-substitution. That's your little footnote in the notes. With a little creativity, we can make it work. All right, so we're going to make it work. So we always do what's under the radical is our u, correct?
Sure.
So that's what I'm going to pick to be my u, x minus 4. So the derivative of u with respect to x, du dx, is just 1, right? Nice. Nice. So dx is just equal to 1 du, right? Okay? Now, if we ever get that, that's going to give us this, x plus 2, and now we have u du, right?
Yeah.
The issue that we have now is that nothing will cancel with x plus 2.
No.
Okay? So, what we can do is take our original u equation and we're going to solve that for x in terms of u. Okay?
Hold up.
So,
What? Those will do the variables and
we're going to solve that for x in terms of u. So go back to this, u equals x minus 4. And I'm going to get x by itself. So I have u plus 4 is equal to x. Okay? So now I can substitute in place of x, I can substitute u plus 4. Okay, so let's see how that affects my problem. So, you have u plus 4 plus 2 times u to the 1/2 power du. Now everything in my integral is in place of u, which is what I want. isn't that u plus 6?
Yeah.
So that's u plus 6 times u to the 1/2 power. Okay, du. Now, can I distribute that u in?
Yeah.
Could. All right, that's what I'm going to do. So I got u to the 1st times u to the 1/2. So that's u to the 2/2 times u to the 1/2. So that is u to the 3/2 plus 6u to the 1/2 du. And now it's an easy integral to take. We just use our anti-power rule. So you get, what is that? U to the 5/2 all over 5/2 plus 6 times u to the 3/2 all over 3/2. Okay? Plus c.
Leave it like that.
No, we got to get rid of those fractions in the bottom of the fraction. So all you do to cancel those bad boys out, just flip it and multiply. 2/5. This one's going to be times 2/3. Okay, so I'm going to write my final answer right here in black. Let's see. We're going to do some simplification. So you have 2/5 u to the 5/2 plus, what is that, 12/3, which is 4, u to the 3/2 plus c. Okay, so now the last step is just going back in and plugging in my values for the u's here. Okay, so instead of those u's, I'm going to have x minus 4's. So I'm going to come all the way up over here and rewrite this thing with the u's plugged back in. So we have 2/5. U is x minus 4 to the 5/2 power. Plus 4x minus 4 to the 3/2 power. Plus c. And that one would be finished up. So sometimes all it takes is just a little manipulation. Maybe I have to solve for that x to plug the x back in.